Now that you've learned about ground control and how it applies to Academy Airport, it's time to learn about how the rules and procedures work with helicopters. Helicopters are different enough that we decided they deserve their own episode. Hello, my name is Kyle Wanner. Helicopters are somewhat unique in how they move around the airport surface. We're going to look at how they do that, along with some phraseology examples today on ATCast.
Thank you. JetBlue 1264 Boston, ground taxi ramp via November and Alpha. Boston Tower, Gulf Stream 717, Echo Pop 30 on the ILS-4 right approach. Hey, there's 741 is checking out. 741 Boston Tower, good evening, thanks for your phone. 737 just inside Melton, I'm like pulling clear land, approximately 1017, 1005. 17, thanks for the service, terminates clock VFR for continuing service, in way back. 117, okay, good night now.
Dan Lindsay joins me from the Tower Lab with more. Dan?
Thanks, Kyle. In the first two episodes of this series, we looked at the rules and regulations associated with ground control, along with some of the procedures and phraseology you'll be using in class. Now let's look at helicopter operations. Although helicopters are similar to other aircraft in terms of the procedures and phraseology you'll be using, there are some special considerations to keep in mind when dealing with them. So let's start out by looking at how helicopters move around the airport. There are essentially three ways a helicopter can move around the airport. If it has wheels, it can taxi just like an airplane. It can also hover taxi, or it can air taxi. What's the difference between hover taxiing and air taxiing? According to the Pilot Controller Glossary, hover taxiing is used to describe a helicopter or VTOL aircraft movement conducted above the surface and in ground effect at airspeeds less than approximately 20 knots. The actual height may vary, and some helicopters may require hover taxi above 25 feet AGL to reduce ground effect turbulence or provide clearance for cargo sling loads. Air taxiing is used to describe a helicopter or VTOL aircraft movement conducted above the surface but normally not above 100 feet AGL. The aircraft may proceed either via hover taxi or flight at speeds more than 20 knots. The pilot is solely responsible for selecting a safe airspeed and altitude for the operation being conducted. The main difference between the two is the speed and altitude. Air taxiing can be faster than 20 knots and higher off the ground, up to 100 feet AGL. Hover taxiing is normally at speeds less than 20 knots and around 25 feet AGL. These operations can produce lots of downwash turbulence from the helicopter's rotors, which can stir up dust, snow, or debris. Be mindful of other aircraft, personnel, or vehicles operating near the helicopter, and provide cautionary advisories as necessary. There is no specific phraseology for this, just the word caution followed by the necessary information in a clear and concise manner. Like I mentioned before, Academy Airport has 3 helipads, but helicopters can also land and take off from runways, much like fixed-wing aircraft do. Of course, they don't need much runway, which is why some instructors may have you send helicopters to taxiway Foxtrot. Helicopters can request takeoff from any point on the field, but in your lab sessions, they will need to taxi to a helipad or runway. Now let's talk to a helicopter pilot to find out what goes on in the cockpit while moving around the airport. UND flight instructor Wes Vandell joins me now. Wes?
Thanks, Dan. My name is Wes Vandell, and I'm a helicopter flight instructor at the University of North Dakota, where we primarily fly Schweitzer H300s. Our primary means of getting around the airport are either by hover taxiing or air taxiing. Generally, pilots prefer the air taxi because it covers a lot more ground a lot quicker. However, the hover taxi is useful if you're only going a short distance and you need to be closer to the ground in case of an emergency. Once the helicopter gets a clearance to hover taxi, we generally just point the direction that we want to travel and start a slow movement forward at a 3-foot hover in order to get to our area somewhere between a slow jogging pace and a fast walking pace. Once a pilot has his clearance to air taxi, you're going to start off by doing a normal takeoff into the wind. Once you get going above ETL, basically somewhere around 16 or 24 knots, you're just going to continue at that speed at an altitude anywhere from the surface up to 100 feet. Generally, we cruise at around 25 feet and somewhere around 20 knots, just to maintain a safe airspeed and altitude combination. ETL stands for Effective Translational Lift. It's basically the point where the helicopter moves from hovering in its own downwash to clean air, and basically we get all kinds of aerodynamic benefits from operating above ETL. It gives us less fuel burn, higher efficiency of the rotors, and generally overall we use less power. The hover taxi is obviously much slower since you're really only moving at a jogging pace, whereas with the air taxi you're anywhere above ETL. It can be anywhere from 20 knots all the way up to 70 knots or faster if you have to cover a lot more ground. Primarily, if you're going to be covering a lot of ground, a pilot will always prefer the air taxi. The only problem is with an air taxi, you need room to decelerate and terminate it back into a hover. With a hover taxi, if you're only going a short distance, it's preferred because there's less setup time and less deceleration time as well. When you're actually taxiing the aircraft, whether it be an air taxi or a hover taxi, the primary consideration for the pilot, besides obstacle avoidance and traffic avoidance, is going to be where the wind is coming from. It is always more difficult to hover a helicopter with a crosswind or a tailwind than it is into the wind. Unfortunately, wherever you're taxiing, it's very rarely into the wind the whole way. If you have a crosswind, the nose of the aircraft would always want to point into the wind, so it makes it much more difficult for the pilot to control. An air taxi, generally you're at a higher speed, so the aircraft is more streamlined and also operating more efficiently, but you still have to terminate the air taxi into the wind if possible. One of our main considerations when we first pick up the aircraft and hover taxi out to a surface is the effect of our downwash. We never want to pick up too close to another aircraft, as the downwash could actually create lift under the aircraft that could pick it up or damage the rotors, or if it's an airplane, even lift the landing gear. If you're moving out to a surface that has snow or any sort of loose sand or anything that could cause a whiteout or brownout, we also are going to hover taxi at a higher altitude than normal. Normally, if we're operating at a 3-foot hover, if we start getting into a whiteout condition, we're going to have to raise our altitude up to somewhere around 10 feet so that we can actually see above the whiteout caused by our downwash. The primary difference between operating an airplane on the airport surface versus a helicopter is that an airplane has to stick to a prescribed route. When an airplane crawls up ground control, they get taxiway assignments to a specific runway. When a helicopter calls up ground control, they just get a clearance to a certain location. How the pilot gets from that position to their assigned location is up to him, and generally they're going to avoid movement areas where we could encounter fixed-wing traffic. When a helicopter receives an air taxi clearance, since there's going to be a large amount of ground covered, it's always beneficial for a controller to advise of any surface traffic that you may encounter on your route. Sometimes this can span the whole length of an airport, so there's not always going to be the ability for the pilot to see everything on the ground as he's approaching it.
All right, thanks, Wes. Coming up next, we'll look at the procedures and phraseology you'll use in class when dealing with helicopter movement on the ground. What are the main differences between hover taxiing and air taxiing? A. Hover taxiing is higher and faster than air taxiing. B. Air taxiing is higher and faster than hover taxiing. C. Hover taxiing is more efficient than air taxiing. D. There is no difference. Both terms mean the same thing. The answer is B. Helicopters can air taxi at altitudes up to 100 feet AGL and at speeds greater than 20 knots. Hover taxiing helicopters typically do so at altitudes of less than 25 feet AGL and at speeds of less than 20 knots. What hazard to other aircraft, personnel, or vehicles is associated with helicopters that are operating near the ground? A. Wake turbulence. B. Jet blast. C. Prop wash. Or D. Downwash turbulence. The answer is D. Helicopters operating near the ground produce downwash turbulence from their rotor blades, which can stir up sand, snow, rocks, or other debris. Now let's look at some of the special considerations to keep in mind when dealing with helicopters. The first thing to keep in mind is that helicopters can produce downwash turbulence, which we talked about in the last segment. Another consideration is that air taxiing is usually the preferred method of moving helicopters around the airport surface. For one thing, it minimizes the effects of downwash turbulence. Air taxiing is also faster and more fuel efficient. Hovering or hover taxiing in close proximity to the ground can be demanding for pilots since it requires a lot of concentration and manipulation of 3 different sets of aircraft controls, as opposed to 2 for fixed-wing aircraft. Air taxiing is easier and reduces pilot workload. Since operating close to the ground is so demanding, especially when the helicopter is being operated by a single pilot, frequency changes should be minimized or not given at all. The 7110 says, avoid issuing a frequency change to helicopters known to be single-piloted during air taxiing, hovering, or low-level flight. Whenever possible, relay necessary control instructions until the pilot is able to change frequency. The note that follows explains why. Most light helicopters flown by one pilot require the constant use of both hands and feet to maintain control. Changing frequency near the ground could result in inadvertent ground contact and consequent loss of control. Pilots are expected to advise ATC of their single pilot status if unable to comply with the frequency change. Like Wes said earlier, wind is a huge factor for helicopter operations on the ground. Be aware that helicopters may need to turn into the wind to take off for air and hover taxiing. So they might have to start traveling in a different direction before turning to follow your instructions. When given a clearance to hover or air taxi, pilots can sometimes choose the route they want to take to get to their destination. At other times, they may be required to follow taxiways just like fixed-wing aircraft, such as if ATC specifically tells them to follow a taxiway. At Academy Airport, helicopters will follow taxiways just like any other aircraft. Finally, be aware of where ground traffic is in relation to helicopters. Pilots of fixed-wing aircraft might not be aware of helicopters operating nearby, especially if the helicopters are above them, such as when air taxiing. Issue traffic advisories as necessary. Let's take a look at the phraseology you'll need to know. Rules governing ground movement of helicopters can be found in the 7110.65, Chapter 3, Section 11. Some helicopters have wheels, and will sometimes want to taxi on their wheels because it's more fuel efficient than either hover or air taxiing. This is called ground taxiing, and the phraseology is identical to what you'd use for fixed-wing aircraft. See episode 20 for more in-depth coverage of that phraseology, but as a quick review, the format is aircraft call sign, taxi to the location via the route. For other helicopters, replace the word taxi with either hover taxi or air taxi as appropriate. Wheeled helicopters can also taxi this way. The format now becomes aircraft call sign, hover taxi to the location via the route, or aircraft call sign, air taxi to the location via the route. Let's take a look at a couple examples in the lab. For detailed information about the layout of Academy Airport and general procedures, see episode 20. Let's have a helicopter, Army 200 Bravo Echo, go from Spartan Aviation to runway 28 right for takeoff from the Foxtrot intersection. The phraseology would be, Army 200 Bravo Echo, air taxi to runway 28 right via taxiway Foxtrot. If it were going to runway 28 left, remember that just like for fixed-wing aircraft, you would state the departure runway first, then the taxi instructions, followed by the holding instructions. Army 200 Bravo Echo, runway 28 left, air taxi via taxiway Foxtrot, hold short of runway 28 right. Let's look at another example. Which Doctor 31 wants to taxi to runway 28 right for takeoff? For this example, we'll have it hover taxi. Which Doctor 31 hover taxi to runway 28 right via taxiway India, Foxtrot. Remember that while hover taxiing, Which Doctor 31 will stay close to the ground and at a lower speed than if it was air taxiing. Note that the phraseology is almost identical to the last example, the only difference being the type of taxi issued to the helicopter. Let's look at one last example. Jolly 1 is ready to taxi, and for this example it will be going to helipad Delta. Since this is a wheeled helicopter, you can instruct it to taxi just like a fixed-wing aircraft. The phraseology would simply be, Jolly 1, taxi to helipad Delta via taxiway India, Delta. Coming up next, we'll review the key points from this episode. Which of the following would be the most fuel-efficient way for a helicopter to taxi? A. Ground taxi. B. Hover taxi. C. Air taxi. D. All are about the same. The answer is A. Ground taxi. It's the most fuel-efficient way to taxi, but only helicopters equipped with wheels can do so. True or false? Hover taxiing in close proximity to the ground is a time of high workload for pilots. The answer is true. Hovering and hover taxiing close to the ground are some of the highest workload tasks for helicopter pilots. Now for a quick review. Helicopters can move around the airport in 3 ways. They can hover taxi, air taxi, or they can ground taxi if the helicopter is equipped with wheels. When hover taxiing, the helicopter will move just a few feet above ground level at about a fast walking or jogging pace. This method is typically used when helicopters have a short distance to travel. When air taxiing, the helicopter will move above the surface up to an altitude of 100 feet AGL and speeds greater than 20 knots. This is often the preferred method of movement because it's faster than ground or hover taxiing and is used when helicopters have a long way to go, such as across an airport or to a distant helipad. Ground taxiing is basically the same as what fixed-wing aircraft do. The phraseology for each operation is very similar to what you'd use for fixed-wing aircraft. If a wheeled helicopter is ground taxiing, the phraseology is identical. Otherwise, simply say hover taxi or air taxi instead of taxi. Hover and air taxiing can stir up debris such as snow, sand, and rocks, so be aware of aircraft, vehicles, and personnel operating near helicopters and issue cautionary advisories if necessary. If a helicopter is being operated by a single pilot, refrain from issuing frequency changes while it is operating near the ground, since hover operations require the use of both hands and both feet. Relay instructions from other controllers until the pilot can safely change frequencies. Like fixed-wing aircraft, helicopters need to take off into the wind and will do so to hover and air taxi. So they may start traveling in a different direction and then turn to follow your instructions. Be sure to issue traffic advisories to both helicopters and other aircraft so that everyone knows what's going on and what to expect. That's it for our series on ground control. If you have any questions, be sure to ask your instructor or the graduate or teaching assistants in your class. Back to you, Kyle.
Thanks, Dan. On behalf of UND Air Traffic Control, the Student Air Traffic Controller Association, and the Aerospace Network, thanks for watching. My name is Kyle Warner. Frequency change approved.
Learn more about UND Air Traffic Control and watch more episodes of ATCast by logging on to www.undsatca.org. Students may interactively test their knowledge by taking the ATCast quizzes on SATCA's Easy LMS page. ATCast can also be downloaded for free to your portable media device. Just search for ATCast on iTunes U.